Those white puffs overhead represent a complex dance of water molecules, microscopic particles, and atmospheric forces that transforms invisible vapor into the clouds that shape our weather. From delicate wispy cirrus at 6 miles high to towering thunderstorms reaching up to 12 miles, each cloud tells a story of atmospheric processes. Clouds form when moist air cools to the point where water vapor condenses into liquid droplets or ice crystals. Three critical elements must converge: sufficient water vapor from evaporation over oceans, lakes, and vegetation, cooling that brings air to its dew point temperature, and microscopic condensation nuclei, dust, salt, and pollen particles that provide surfaces for water vapor to cling to. Different formation mechanisms produce distinct cloud families. Cumulus clouds develop through convective processes, appearing as puffy formations indicating unstable conditions. Stratus clouds form in stable air, creating uniform gray layers. Cirrus clouds develop at high altitudes where extreme cold creates ice crystals. Cumulonimbus represents vertical development extremes, forming towering anvil-shaped structures that produce severe weather. The most common cooling process is adiabatic cooling, occurring when air rises and expands due to decreasing atmospheric pressure. As air expands, it loses internal energy, dropping temperature at about 10 degrees Celsius per 1,000 meters. When this cooling reaches the dew point, water vapor condenses into tiny droplets. Radiational cooling happens on clear nights when ground surfaces lose heat to space, chilling air above. This process creates morning fog or low stratus clouds, particularly in valleys where cold air settles. Weather fronts provide a third mechanism, where warm air rises over cooled air, creating widespread cloud formations spanning hundreds of miles. Once air reaches saturation, water vapor condenses onto condensation nuclei, forming microscopic droplets typically 10 to 20 micrometers in diameter. Cloud type depends on atmospheric stability. Stable conditions produce layered stratus clouds through gentle lifting. Unstable conditions create strong updrafts, leading to vertically developed cumulus or cumulonimbus clouds that can mature into thunderstorms within 30 to 45 minutes. Mountains create unique cloud formation through orographic lifting. When moist air encounters mountain ranges, it's forced upward along slopes, cooling adiabatically and often creating spectacular lenticular clouds, smooth lens-shaped formations hovering near peaks. Coastal regions experience marine layer formation when cool ocean air moves inland and encounters warmer surfaces, creating characteristic fog common in areas like San Francisco. Cloud formation reveals atmospheric physics in action, where temperature, humidity, air movement, and microscopic particles create the diverse structures we observe daily. This understanding transforms sky gazing into reading the atmosphere's story, recognizing unstable air in towering cumulus or approaching fronts in high cirrus streams. Far from mere water droplet collections, clouds serve as dynamic indicators of our ever-changing atmosphere. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.